Here's a system that uses AI to triage support tickets, waits for human approval where needed, and survives a server crash without losing a thing. In the next 15 minutes, you'll see exactly how to build this with Temporal. Maybe you've written an AI support ticket triage workflow that looks something like this. We can run it. You'll see it processes 2 tickets in this case. 1 ticket is a lower priority because it's just a password reset, and the other ticket is a critical priority because someone got hacked and exposed PII inside of their ticket. And so we need our AI system to redact this information, correctly classify the ticket, and then wait for human approval to ensure that everything was done correctly. Here we'll see that we're iterating through every ticket, and then we're performing 2 steps. One is scrubbing a PII, and then the other is classifying a ticket. Both of them are using OpenAI underneath the hood. Now, there are at least 2 problems with this type of implementation. Number one is that obviously AI can be wrong. What happens if it misclassifies a ticket? That's where human approval comes in. And number 2, systems fail. Servers go down, networks have glitches, data centers go down, and of course, it'll all happen on a Tuesday. To solve these challenges, we can write our own code to figure out how to do retries, backoffs, what happens if we fail in the middle of an activity, how do we restart exactly from that activity? We can code all of that logic ourselves. It'll probably be a lot of code, a lot of complication. Or we can try to create a smarter system using a solution like Temporal. Let me show you exactly what I mean. I'm starting the process that will support our triage workflow, and then I'm executing the entire flow in order to be able to triage tickets. The very first thing we'll notice about Temporal is that we get this UI that allows observability into what's going on with our system. We see here that we have a workflow with a triage ticket of 001. We can see all of our steps for the triage. So we can see this scrub PII method. You can see the inputs. You can see the outputs of that event. We can go into classify ticket. So you can see this method as well, exactly the same business logic, getting a password reset and then getting a classification, all of it using OpenAI. And then the final step, which normally we would have to implement the step ourselves. However, with Temporal, it's extremely easy, is adding a human in the loop. There's this event that will wait for up to a day for a human to send an approval. And we can send an approval via the UI, the CLI, via APIs, doesn't matter. And then that ticket will either be approved or rejected. And then based on that, we can proceed with our next steps. Here, I'll send the signal to approve the ticket. Ticket approved. Our entire process finished successfully. And now we're moving on to the second ticket. The first activity is to scrub the PII. Let's see what the input is. Oh, this is the very dangerous ticket, the one where the account was hacked, credit card information was shared, and we need AI in order to be able to redact it. And so here is the result of scrubbing the PII, redacting the credit card. And then that information gets passed into our ticket classification. You can see the input here is with the redacted PII. The urgency is high. Yes, someone getting hacked and charged $500. That is very significant. And then we wait for human in the loop approval to ensure that everything is okay. One of the other really beautiful things about Temporal is that ultimate goal is to add durability to our AI workflows. And so what I can do is I can come and stop the process that I started before. And the process is completely stopped. However, inside of our UI, we can see that our triage flow is still continuing. You can see, first of all, by all of the moving bars, but number 2, you can see by this duration down here that this has been running for over 2 minutes. And even while I'm recording this video with you, this process continues to execute, still waiting for human approval. I'm restarting the service, refreshing the browser. We've been running this for over 3 minutes now. It can go on forever because the AI did a wonderful job of obfuscating the information. I'm approving the ticket, and our ticket triage flow has completed successfully. And yes, don't worry, all of this is using fake data. No real humans were harmed in the making of this video. Let's build this. By the way, the repo is publicly available. You can find the link in the description below. Like here in our support triage workflow implementation. A workflow, think of it as the entire process, the flow where we want to execute the steps in a specific order. In this case, we're triaging a ticket. So we have the scrubbing of the PII, classification of the ticket severity, human in the loop approval, and then completion of the workflow, the flow. One of the coolest and most valuable things to configure via Temporal are the activity options. And this removes all of this complicated logic that we previously had to write. Temporal has it built in for us inside of their Java SDK. We can set a back-off coefficient. We can set an initial interval of how long it will take before we retry our step again. Maybe our AI model is taking a little bit longer because OpenAI just released a new model and they have a lot of traffic going there, or we've definitely seen a lot with Anthropic. Anthropic will get overloaded whenever they release a new model, and then service will slow down. And so maybe that initial interval that we want to wait for before we try an activity might need to be 10 seconds for our AI versus 1 second for a simple API request. This whole thing that you see here, this is a workflow. The next step that we want to do is we want to wrap all of our non-deterministic methods, interactions, API calls, database calls into activities. An activity can be non-deterministic. A workflow has to be deterministic. And simply by wrapping our non-deterministic methods inside of activities, this is what makes them retriable automatically by Temporal. This is what gives them durability. This is what gives them visibility inside of the dashboard. Next step, we had a triage ticket method in our old implementation. We're literally just moving that over inside of our workflow, performing all of the same steps, but instead of using the implementations of our AI scrubber, our AI classifier, our human in the loop, we're replacing them with temporal activities. Look, before, just a direct method call. In fact, this logic inside of Scrub PII remains exactly the same. This is business logic, does not need to be modified for temporal. Now, we're just calling it from the scrubber, which has a concrete implementation that's moved into a class, performing all the same operations as before. And we do the same thing for the ticket classification. Let's take a look at the activities. So every activity is non-deterministic and gets wrapped in an interface using the temporal activity interface and activity method. And then it gets an implementation. And both of them look very similar for pretty much all implementations. In this case, we're taking in our concrete business logic implementation for our PII scrubber using OpenAI. And then we have our method that we had before, passing in the ticket text, and our scrubber in this case is scrubbing the PII. Our PII scrubber is exactly what the scrub PII method used to look like. We wrapped it in a class and are using the concrete implementation inside of our workflow. If you look at the ticket classifier activity, looks very similar to the PII scrubber activity, has an activity interface and has one method called classify ticket. And then we have an implementation. We have a concrete ticket classifier, which will have the same exact logic as we had before. We have the implementation that takes in the ticket classifier, and then we use the ticket classifier to classify our ticket. If you want to look at that implementation, we can see it here. Same exact thing, copy and paste from our old implementation into our new durable implementation. How do we actually start up this workflow? And for that, we need a worker. A worker is exactly what you saw me start over here in the terminal. A worker will actually poll temporal to figure out what else is next in the queue. And so you can have many workers creating redundancy. You can have workers located in different regions running different workflows, and they'll keep polling temporal to figure out what's next in the queue, and they'll process that accordingly. In Java, this is a entry point method. You'll connect to temporal with a service and a client like that. You'll create a factory and the worker that looks like that. You will register your workflow implementation with the worker so that the worker knows which workflows it's allowed to execute. You can have workers that execute different workflows as well. So you can actually even scale your workers depending on the workflow. For example, maybe we have a workflow that classifies tickets and another workflow that redacts PII information from those tickets. And maybe the redaction takes much longer. And so that process is much slower. And so maybe that part needs a lot more scaling. And so we can have a lot of workers registered with that workflow, ultimately creating better scalability. Here you can see we are adding our business logic instances. We are registering all of our activity implementations. And then we are starting our worker. We can start the worker. We can start our entire workflow. We can see our workflow started processing the support ticket. If we want, we can stop the worker. And this is where the magic happens. Even though our process is down, Temporal is keeping everything up and allows us to restart at the exact same place where we left off, ultimately saving us time and money. Because, token usage is not going down anytime soon. And the final important piece, the fourth of all of this, is the starter. Let me show you this architecture diagram so you understand better how all of the pieces connect. So what you've seen is the temporal server. And we can also start the temporal server like this. The temporal server interacts with a number of systems. I already showed you the worker. The worker polls for new tasks coming in and then executes those workflows and activities. I kind of showed you already the external system, which is the CLI API. In the UI, I approved or rejected a ticket. That is one way to do it. I'll show you another way to do it in a moment once we're finalize everything. The client is the starter. It starts the workflow and it gets the results. Here is us starting that worker service that you've seen before. And when we execute this command in the CLI, which starts the workflow, you can see that it's actually pointing at our starter class. And so when we run our starter, that begins our workflow execution, which executes the activities that I've already showed you, scrubbing PII, classifying a ticket, deciding whether the ticket needs a human in the loop or not, waiting for the human in the loop, and then returning triage result. You've already seen the two activities, the PII scrubber and the ticket classifier, and this is how the data flows. We get the raw text, such as PII. Activity 1 will scrub the PII. This is using AI. Activity 2 will classify the ticket, give it a category, give it an urgency, a confidence, all using AI. The workflow will decide, does this ticket need a human in the loop review or not? Using the signal, we will wait for the human approval if it's required. And then when the ticket is approved, it'll get a triage result. If it's not, it'll get also a triage result. And so with all of that said, it's important for us to visit the starter and to understand what it looks like. It's another main entry method. Again, connecting to temporal server and worker, just as we did in the worker app. But here is where the logic to iterate through our tickets comes in. This is where everything starts. And so we can put in here tickets. Of course, they're hard-coded, dummy data in a real-world system. You'll create real API calls to your backend to process this queue of tickets. We're creating our workflow ID, which is what you've seen whenever we're running our workflow. For example, if I run this workflow and pull that up, refresh. This is the workflow ID that we are creating a workflow stub, passing in our workflow interface, performing the operation that we want to perform. In this case, triaging a ticket, and then just doing some logging. The starter is relatively simple in this case. And with that, you can now understand all of the pieces being connected. We have our workflow here with our workflow ID at the top. The steps inside of the workflow, also known as activities, are executed here. Here is our scrub PII activity. It gets an input and an output. Here is our classify ticket activity that receives the input from the scrub PII activity. In this case, there's nothing to scrub. And then we have our human in the loop activity, which is created using a signal from temporal. And then that waits for a signal. Now, let me show you something very cool. You've already seen how we can use the UI here to approve a ticket. Of course, in a realistic system, you're not going to use the temporal UI because most likely in this kind of triaging system, there'll be a human that's monitoring some kind of a board in order to approve or deny tickets. We can also do this via CLI. I'll show you. So using Temporal CLI, we can pass in a signal, our workflow ID, the input for the approved ticket method. Workflow succeeded. You can see now our support ticket 001 is completed. So just to summarize what you've seen here, we've got a workflow where AI makes decisions whether to redact PII or not and how to classify a ticket. Humans approve the risk, and Temporal protects progress. Temporal helps to remember stuff even better than I remember where I parked my car. If you want to build this yourself, the repo is linked in the description. If you want a simpler place to start that'll teach the fundamentals, go to the quick start. That's also in the description. And if you enjoyed this type of tutorial, give it a thumbs up or a comment so that I know whether to create more of this type of content for you. And if you didn't enjoy it, let me know what type of content you'd like to see. Other than that, my name is Nikolay Advolodkin. Have a beautiful day, my friend.